So I'm going to start things off pretty easy by going over some short long division problems. Wait, why are there duplicates? So basically long division, and this is the way that I am expecting you to do it, as well as the way that many of your 6th grade teachers and 7th and 8th grade teachers are going to expect you to do this. They are not going to want to see that. It's called the Big 7. The Big 7 might have worked for you well enough in elementary school. However, whenever you start learning about how to divide decimals, for example, the Big 7 is going to hinder you a lot. This method allows everything to stay lined up nice and even, which helps a lot whenever you start getting into decimals. I'll just start off here since it's a pretty straightforward and easy problem. You're going to take that 2 and see how many times it can go into the other number ahead of it. Now there are a couple ways you could do this. One way is being familiar with your multiplication tables. I know that 2 can be multiplied by 2 to give me 4, so I don't have to think very hard. Somebody who isn't as well versed with their multiplication tables, however, is going to have a little bit of a harder time. And they are likely going to have to resort to counting by that number and keeping a tally to see how many times it does fit. But that's something that you know that you might have to work on or not. In our case, 2 goes into 4 2 times. So we will write that number above it. 2 times 2 gives me 4. It goes in 2 times, which gives me a total of 4. I subtract that number from the number above it, and that leaves me with 0. I then take the next number in the sequence and carry it downward. And I repeat the step before. 2 goes into 4 2 times. 2 times 2 will give me 4, and I subtract to give me no further numbers to compute. The answer for 44 divided by 2 is 22. Moving on to the second problem in the sequence, we see that there's a problem. 4 does not go into 3. 4 is too large, unless you were thinking of fractions, but that's a little bit further ahead than I want to be. 4 does not go into 3, so what I would like you to do is actually write that it does not go into 3 at all. It fits exactly 0 times. That's going to come in handy more so when you start dealing with decimals where everything needs to be lined up. 4 goes into 3, 0. Next, you have to look at the entire sequence, or if you are really particular about the way your problems are laid out, you could do 0 times 4 gives me 0, and subtract that 3. Next, you carry down the next number in the sequence and proceed as normal. 4 goes into 36, however, a lot more than 0 times. It goes into it 9 times if you are familiar with your multiplication tables. If not, you could simply do 36 divided by 4, but then again, I'm helping you practice division. So you may have to count by 4s. 4, 8, 12, 16, 20, 24, 28, 32, 36. That's 9 times. We write our 9 up here and do 9 times 4. That gives us 36, as we just demonstrated. We subtract that and gives us no further numbers, but we do still have one more up here. We do not neglect it. We continue to carry it down. And of course, 4 goes into 4 1 time. We subtract that out just to finish up our problem, and we get that 364 divided by 4 is 91. You wouldn't necessarily have to write that 0 in the end if, for example, there was a little section for you to write your answer. You could really just write 91. But when you're showing your work, it's useful to have that 0 there as a placeholder. For this last problem, I'd like you to pause the video and give it a shot on your own. Hopefully you took my advice and paused it and tried it on your own, but if not, here we go anyways. 2 does not go into 1, as with the last problem, so we write a 0 above it. 2 does go into 13. I'm going to do this problem without carrying down both numbers. 2 goes into 13 6 times evenly. 6 times 2 gives me 12. It does not actually go into it all the way. There will be one number left over. 13 minus 12 gives me a remainder of 1, but luckily I still have one more number left to go. I carry down my 2, and I can recognize that 12 is definitely divisible by 2, and that will give me an answer of 6. 6 times 2, of course, gives me 12. We subtract to get our answer of 66 for the problem 132 divided by 2. What I'm going to do now is I'm going to scroll down just a little bit so that way you can see a couple other example problems, a few for you to try on your own and perhaps a few for me to walk through with you. Once again, I don't plan on doing all 4 or all 8 of these problems, as you do have a calculator that you could use in order to check your work at the end. But go ahead, take a moment, pause the video, and see what you're able to do on your own. Okay, hopefully you paused it again. For these problems, I'm going to simply do this one and this one. The two on the one in the middle and the one on the end is going to be your responsibility. 8 does not go into 5, so I write my 0. 8 does go into 52, although not evenly. 8 will go into 52 6 times. 6 times 8 is going to give me 48, and I will subtract that. That gives me a leftover of 4, but I carry down my 0 and see that 8 goes into 40 5 times, giving me my solution that 520 divided by 8 is 65. This problem here on the end, similar situation. 2 does not go into 1, but it does go into 11, though not evenly. It goes into 11 5 times, giving me 10. When I subtract 10, I still have 1 left over, except when I carry down my 8. 2 goes into 18 9 times evenly, and 9 times 2 will give me 18. Subtracting that out reveals that my final answer is 59. And that really is all there is to long division. Now, this whole process will become far more complicated. Well, no it won't. This process will become a teeny tiny itty bitty bit more complicated once we start dealing with decimals. It really doesn't get that much harder, barring the fact that you will have to draw 2 dots and a 0. If you are capable of drawing 2 dots and a 0, then you will be just fine when it comes time for decimals. I'm going to leave you here with this last slide. Now, this slide has 6 example problems, each of them very challenging. But it's important to note that these are problems that you may be expected to solve in the 6th grade. Just as an example, I have the objectives that we are currently going over in class right now up on the board. And the objective reads that students will be able to fluently divide multi-digit numbers using the standard algorithm. Long division, written in this form, is considered the standard algorithm. So you will be expected to divide multi-digit numbers. This is a multi-digit number. A single-digit number would be an example of the problems we have already done. So, for these problems, I will do a handful with you, which is to say probably only 2 because I am running low on time, and I don't want the recording to cut out. It also doesn't help that for whatever reason they're choosing this afternoon to constantly check the intercom, so I keep having to cut part of my video out. Anyways, I'm going to start with this one since I'm over here right now. 64 does not go into 1, so I will indicate that by writing 0. 64 also does not go into 17, and I will indicate that by writing in the additional 0. Now, I know 64 will go into 172, but I'm not entirely sure, so I'm going to have to estimate. I can estimate by saying this is probably about 170. I can say this is about 60. I know that 60 will make it to 120, and that is 60 times 2, but 60 times 3 would be 180. So for right now, I'm going to go with the assumption that I can probably only fit 2 times. 2 times 64, if I do the math really quick, I know that 2 times 4 is going to give me 8, and 2 times 6 is going to give me 12, meaning my answer should be 124. I'm going to subtract that from 172, and that should give me, if I borrow from this 7 and change that 2 to a 12, this is going to give me an 8, that will give me a 4, and this a 0. I'm then going to carry down this 8 from before. And now I have an even more challenging problem ahead of me. I have to figure out how many times 64 will go into 488. How many times does it go into 488? Let me show you what I'm thinking of. 64 and 7. If I do this multiplication really quick, I come out with an 8 here, carry my 2. 7 times 6 is going to give me 42, plus that 2 gives me 48. Although initially, I just went with 64 times 5, and pretty much knew right away it was going to be 320. It was just a matter of me estimating that it could probably fit 2 times after that. So, I will write my 7 up here, write my 488 down here, subtract, and I'm finished. These types of problems, as you may have just seen, require a little bit more finesse when it comes to your multiplication facts. You're going to need to be rather quick with them, so by the time you get to long division, it is very, very, very important to already be very fluent with your multiplication facts. Otherwise, these sorts of problems, even if there are not many of them, may take you far longer than you would want. The next problem I'm going to do is right here. 5,360 divided by 67. In this case, once again, similar to that, I know that 67 does not go into 5, nor does it go into 53. I'm instead going to have to try to estimate how many times 67 goes into 536. I'm going to estimate that it probably goes in 8 times. Showing my work for that example, I'm going to say 8 times 7 is going to give me 56. I don't know why that took me so long to think of. Next, I will do 8 times 6, which gives me 48, plus 5 is going to give me 53. Conveniently enough, I actually hit the nail right on the head. I didn't expect that to happen. But I'm going to do 8 times. And 8 times 67 will give me 536. When I subtract this out, I don't actually have any more numbers. Now, this last step is very important because I have seen students do problems like this before, and they will put the final answer to be 8, even though clearly 67 does not go into 5,360 only 8 times. What you have to do next is you have to carry down that one remaining 0. And you do, silly enough, have to ask, how many times does 67 go into 0? While the answer is laughably obvious, it does not go in at all, you do need to indicate that by putting a 0 in your answer. Without including that number up there, you run the risk of forgetting to put it down at all and instead answering with 8 instead of the correct. And that's all there is to it. If you require additional assistance, there is a link that I'd like to direct your attention to. It was one I stumbled across by accident that appears to be free in nature and has all sorts of multiplication and division flashcards available for you to use. Here's the website now. I went ahead and put it up, and since I know that address bar is probably impossible to see on this video, here's the website written out. It is varsitytutors.com/a+math. If you come here, the website will look like this. And you can actually select from math games, some flashcards, worksheets, and you can choose, if you know your weakness is multiplication, you can actually choose multiplication or division, geometry, whatever. I also just happened to notice this. I can't believe I didn't notice it before, but you can actually get an app, I suppose, for this exact place on both the App Store, the Google Play Store, as well as, I'm not quite sure how it would work, but on Amazon and iBooks. So check this place out. I know that it's got a lot of really good flashcards that I know would help a lot of my students. And maybe they could help you as well. At any rate, I'm done for the day. They seem to have finally stopped making the announcements, so I'm going to get out of here before my video cuts out like the last one. This is Mr. A. Have a nice night.